Okay, so as you guys know, this week we're talking about multiplying polynomials, and all we're doing today is taking a step up to include trinomials in our multiplication. That's three-term polynomials. Our strategy is going to be exactly the same. Rewrite in standard form and use 0 as a placeholder. We won't really get to that until later in the week. Then we're going to distribute one polynomial to each term in the other polynomial. And finally, we'll combine like terms and write our answer in standard form. So we have two different methods for doing this. The first method is the traditional distributive method. So what that method tells us to do is take each term in the first polynomial and distribute it to everything in the second. So I'm going to distribute the 3a first, and then I'm going to distribute the positive 2. Each gets distributed to negative a squared, to negative 5a, and to positive 3. So let's distribute that 3a first. 3a times negative a squared, that's negative 3a to the third. 3a times negative 5a, right? 3 times negative 5 is negative 15, and a times a is a squared. And 3a times positive 3 is positive 9a. Then we're going to look at distributing the positive 2. So 2 times negative a squared, that's negative 2a squared. 2 times negative 5a, that's negative 10a. And 2 times 3, that's positive 6. So next, all we're going to do is look for any like terms that we have, and we should see a couple show up. Negative 15a squared is a like term with negative 2a squared. And 9a is a like term with negative 10a. So let's write our final answer in standard form with the exponents going down, right? So we start with the negative 3a cubed, the highest degree term. Then we're at our a squareds, but this is a like term with this. Negative 15 minus 2 is negative 17a squared. 9a and negative 10a are like terms. 9 minus 10 is negative 1, so we have negative 1a, or just negative a. And then we get to the plus 6 at the end. And this is our final answer. So let's use our other method, the box method, and check that we get the same thing. So the box method tells us to do the same thing. Take everything in one polynomial, multiply it by everything in the other, and then just add them all together. So we're multiplying everything first. 3 times negative 1 is negative 3. And then the a times a squared using exponent rules is a to the third. 3 times negative 5 is negative 15. And a times a is a squared. 3 times 3 is 9. And we have this a. 2 times negative a squared is negative 2a squared. 2 times negative 5a, right? 2 times negative 5 is negative 10, and we have this a. And positive 2 times positive 3 is 6. So you'll notice that we have like terms showing up diagonally across from each other. And if our box was larger, these diagonals would just continue to give us more and more like terms along that line. So those are like terms, and these are also like terms. So let's write this all out using addition and subtraction and making sure we combine the like terms along the way. We'll start here, and we'll just kind of work our way to the right. So we have negative 3a cubed, negative 15a squared, and negative 2a squared will just combine right now into negative 17a squared. 9a and negative 10a, 9 minus 10 is negative 1, so that's negative 1a. And then we have this plus 6 at the end. And we should notice that this matches exactly the answer we got from using the traditional distributive method. Let's look at one more example. The only difference here is that the trinomial comes first before the binomial, but our method is exactly the same. So our first option, we'll start with the box method this time. Notice that the box is longer this way this time. It's no difference. If you wanted, you could even write the x minus 1 here and the 5x squared minus x minus 1 here, and it would look exactly like we had in the top. So 5x squared times x is 5x to the third. 5x squared times negative 1 is negative 5x squared. Negative x times x is negative x squared. Negative x, or negative 1x times negative 1 is positive 1x, or positive x. Then we have negative 1 times x, and negative 1 times negative 1 makes positive 1. You'll notice again, just like we had earlier, that we have like terms showing up diagonally across from each other. Negative 5x squared minus x squared, and x minus x. So let's write this out in standard form, starting up here and just working our way down and combining like terms along the way. So we have 5x to the third. Negative 5x squared minus 1x squared is negative 6x squared. X minus x, these actually cancel each other out. 1x minus 1x. So these cancel each other out, giving us 0x, which we don't really even need to include there because that's nothing. So these cancel. And we just have plus 1 at the end. So this is our final answer. Let's check that it matches with what we get with the traditional distributive method. So again, with this method, we take each term from one polynomial and distribute it to everything in the other. So we distribute 5x squared to x and to negative 1. We take negative x and distribute it to x and to negative 1. And finally, we take negative 1 and distribute it to x and to negative 1. So 5x squared times x is 5x to the third, and 5x squared times negative 1 is minus 5x squared. Then we'll distribute the negative x. Negative x times positive x is negative x squared. Negative x times negative 1 is positive x. And finally, we'll distribute this negative 1. Negative 1 times x is negative x, and negative 1 times negative 1 is positive 1. So we're going to just write this all out in standard form, and we're just going to combine any like terms that we have. So notice that we have like terms showing up right here, negative 5x squared and negative x squared. And we have like terms also showing up here, positive x and negative x. So we have 5x cubed. We combine the like terms. Negative 5 minus 1 is negative 6x squared. And x minus x, these actually cancel each other out. So we don't get any x term at all. We're just left with plus 1 at the end. And again, you'll notice that this matches exactly what we had from the other method. So either way you choose to do this is fine. Again, if you have any questions, go back, rewatch the video, or email your teacher. And you have a few problems to try for this week's weekly practice.